good evening. We will start with these assignment and book questions now. If somebody is confused what is revision notes, they have been posted in our group for a very long time now. I'll just show you. So here we have on the top, you can see revision notes. Okay, so you can just write RN and then write the chapter number and write whatever. So see, of course, for CM1, this revision notes, these are chapter wise. Some chapters are combined. Okay, and a lot of questions we have already covered in the assignments that are given to you. Okay, so a lot of questions might be same, but a few will be different. Okay, so you can go through them. But I would suggest do this after you have done all the assignments. Okay, these are more additional practice questions that you can do. Okay, so anyways, and then see, for chapter 1 to 14 we have separate the CM1 revision notes, chapter 1 to 14, and this for 15 to 28 we have different CT5 revision note. This is old course. Okay, so these are good for practice again, but some questions might be out of our course. So as you solve, if you feel like you're not getting some question, you can ask me. Okay, so that is why I say you should solve these after you have done all of your assignments. Okay, so if you have completed, let's say chapters up to 14, and or maybe up to what we are talking about, you have done all the assignments, then you do these for practice purposes. Anyways, let's take chapter 11 doubt, 16, 22, 24. 16th third part, calculate both the capital component and the interest component of the 7th repayment. So capital component and interest component is the doubt. So the others I will take it from the answers that are given. So I think, okay, this is the, here answers are not written in the correct order. This answer is for the second part, and I think these two answers are for the third part. That is how I remember. The loan was taken out on 1st September 1998 and was repayable by the following increasing annuity. The first repayment was made on 1st July 1999 and was 1000. Thereafter, the payment were made on 1st November, 1st March, 1st July and 1st March 2004 inclusive. Inclusive just means they are including every values that they are talking about. Each payment was 5% greater than its predecessor. The effective rate of interest throughout the period was 6% per annum. So we have compound increase. So you can definitely take it as I dash and solve it like a normal loan schedule question. But let's say if you don't take it as I dash, if you take it as geometric progression, let's see how we would be doing. Okay. So okay, Divya, you're saying the revision notes doubts are from chapter 12. Okay, but there you wrote chapter 10 and 11, I guess. Anyways, okay. I don't think we'll be able to cover these many doubts, and I will cover always the revision note doubts at the end. Okay. You wrote booklet 3, chapter 11, 12. So I think that was 17 and 20. Okay. So these questions are from chapter 12.
Sir, 5 and 11 are also from chapter 12.
5 and 11 are also from chapter 12. Okay. Okay. Just no problem. So we'll try to complete as much as possible. Okay. So we are going to take that our loan is 17,692. Then the amount of the capital repaid on 1st July 1999 was this much. Okay, that is not going to be used in this one. Now when we are trying to calculate both the capital component and the interest component of the 7th repayment, we would want loan outstanding after our 6th repayment. So loan outstanding after our 6th repayment. So the repayments are 3 times a year, right? 1st July. Thereafter the payments were made on 1st November, 1st March, 1st July until yes. So we're talking about 3 times a year. So definitely you can do effective calculations. Okay, no problem there. But yeah, actually it would be better if we do effective calculations. But of course, here when I say L6, I can calculate it using geometric progression as well. So when we are calculating our L6, this would be actually 1.5 year because actually no 2 years because we are having 3 payments each year. So 1 by 3, 2 by 3 and 3 by 3 would be 1, and then whatever 1 by 3. Okay, and so on. This is how our time frame is going to go. First payment would be here, second payment would be here, but it would be 1 plus b, then 1 plus b square, 1 plus b cube, because we have increase, and so on. Each payment is 5% greater than the previous one. So 1 plus b raised to 4, 1 plus b raised to 5, and 1 plus b raised to 6. Now we want loan outstanding after 6 payments. So these are 6 payments. We want loan outstanding after 6 payments. So we'll say it is nothing but the present value of all the remaining payments. First of all, in total, how many payments did we actually have? So 1st July 1999 was the first payment. Okay, 1st July 1999 was the first payment. After that, the payment was November, then March, then July, and so on till 1st March 2004. So if we take our zero is going to be 1st March 1999. 1st March 1999 is our 0, and 1st March 2004 is our n. So how many years are we talking about? So that is actually 5 years, right? I can subtract these two and I'll get 5 years. So we are going for 5 years. Okay, and 2 years have already gone. So we are left with 3 years of payment. 3 years of payment, 3 payments per year. So we are left with 9 payments, right? So after this we have 9 payments. What is the first payment that we will be seeing? First payment we'll be seeing is 1000 into so we'll have 1000 into 1.05 raised to 6. This is the first payment that we'll see. Okay, this should be discounted for how many years? 1/3 year. Next payment is going to be 5% greater than this one, so 1.05. That should be discounted for 2/3 of a year. 1.05 square. 1 year, and so on. What would be our last payment? Last payment, 3 years, that means we had 9 payments to go. So I will have v raised to 3, okay, and 1.05 raised to something. You can count, right? 9 payments raised to 0, raised to 1, raised to 2, and so on. So this would be raised to 8. So again, you can take v raised to 3 out, or you will use geometric progression. We'll have 1000, 1.05 raised to 6, v raised to 1 by 3, and GP. We have 9 payments. 1 minus 1.05, v raised to 1 by 3 raised to 9, upon 1 minus 1.05, v raised to 1 by 3. Rate of interest was 6% per annum. So this would be the loan outstanding. Now you can calculate interest component. Say 7th payment would be L6 into effective rate of interest, that would be I 3 by 3. And capital component would be 7th repayment minus the interest component. 7th repayment we knew was 1000 into 1.05 raised to 6. So 1000 into 1.05 raised to 6. This was the 7th repayment minus interest. So capital becomes 1078.43. I hope that is what our answers are. Yes, this is the capital component, this is the interest component. Okay. Question number 22. We have Akash wants to take a loan of 10 lakhs from ABC Bank for his higher education. The bank charges an interest rate of 7.5% per annum convertible quarterly on this loan. The bank offers the following two options for loan repayment. Option 1, no repayment will be required for the next 2 years. After 2 years, the accumulated loan will need to be repaid over 20 equal half-yearly installment payable in advance. Okay. Option 2, only interest will be needed to be paid over the next 2 years annually in arrears. The loan outstanding will be needed to be paid over 10 increasing installments, increasing at the rate of 10,000 per annum, payable in advance. Calculate the first installment amount to be paid after 2 years of the loan for each of the above options. We'll say option 1. First thing, I'll calculate I. So this is I. Okay. In option 1, no repayment required for the next 2 years. So that means in 2 years time, the loan will be accumulating. That means the interest will be accumulating. So we can say after 2 years, loan outstanding will be equal to how much? 10 lakhs into 1 plus I raised to 2. So this will be the loan outstanding. This much loan is supposed to be paid in 20 equal half-yearly installments payable in advance. So this will be equal to I'll write it as 2x A payable 2 times in advance, and for how many years are we talking about? We are talking about 10 years. So let's calculate our x value. We want D2 in the denominator. definitely made some mistake. I'm getting 80,000 installment. So I made some mistake somewhere. Actually, no, 80,000 installment is correct because the loan is of 10 lakh. Most likely this is correct. 80700.37. Okay. Yes, that's correct. What about option 2? In option 2, only interest will be needed to be paid over the next 2 years. The loan outstanding will be needed to be paid over 10 increasing annual installments. So first of all, because only interest was paid in those 2 years, so after 2 years, the loan outstanding will still be 10 lakhs because we paid only the interest. Then now this would be paid in 10 increasing annual installment, increasing at the rate of 10,000 per annum payable in advanced. So this loan outstanding will be equal to whatever we are talking about, x minus 10,000 ADU payable 10 times plus 10,000 IADU payable 10 times. Okay, we have to calculate our x. For this I'll just calculate ADU 10 separately. I should have stored the value. I'll just store it right now. I think it was 0.077136. Store it. See. IADU 10. So x will be 97649.15. Okay. B part, calculate the total amount Akash needs to pay in case of option 2. Total amount. So we know first payment was X, then we had X plus 10, X plus 20,000, X plus 30,000 and so on. We'll talk about that later, but before that we had 2 years of interest only payment. So total amount will be interest paid in first 2 years plus we will have, see, first payment was X, then X plus 10,000, X plus 20,000, X plus 30,000. This goes on for 10 years. Last payment is X plus 90,000. So you know arithmetic progression AP formula is going to be 2 times okay, no, sorry, n by 2 into 2a plus n minus 1 t. This is what arithmetic progression formula is sum. So that ways you will have 10 by 2 into 97 649.15 plus n minus 1 would be 9 times 10,000. What was the interest paid in the first 2 years? Interest paid in the first 2 years it would be 2 into 10,000 2 into 10 lakhs, right? This is 10 lakhs into I. This will be the interest paid plus whatever this might be. Rate of interest was this much plus 1449. So the total payment. Right, nearly same. Then C part, calculate the amount of the capital repaid in the 9th installment in case of option 2. So in this case, when we do not have a lot of repayments left, so here you can see 9th installment. So we would take loan outstanding after 8th installment. So to calculate loan outstanding after 8th installment, I have only 2 payments left, right? This is time 8, loan outstanding I have to calculate here. We'll have time 9 and time 10. Okay. So the 9th installment, whatever it is, X9 and X10. So I can say loan outstanding at the 8th installment would be just X9 discounted for 1 year and X10 discounted for 2 years, right? Rather than making an increasing annuity formula here for just 2 years, this is what I will be doing. Just easier. What would be our 9th installment? So 9th installment will have 80,000. So I will just have here X, we calculated X here, that is what I am taking, plus 80,000, that is what our 9th installment was, plus X 90,000 b raised to 2. Okay. So accordingly The loan outstanding after 8 years, or after 8 payments actually. One capital component, for that we'll calculate our interest component, 9. Late into I. Capital component of 9 will be so interest component was 97649.15 plus 80,000. Yes, answer. Okay. Question 24, fourth part. So if your loan of 3 lakh is to be paid over 12 years by equated monthly installments, the rate of interest on the loan is 8% per annum effective. Calculate EMI, principal and interest component, 57th installment. Calculate the loan outstanding immediately after the payment of 60th installment. If the loan outstanding as calculated in part 3 above is to be repaid over the next 5 years at the same rate of interest of 8% per annum effective through annual installments increasing at 5% per annum compound, calculate the initial installment. This is actually very straightforward. So we'll take loan outstanding from the third part. Loan outstanding from the third part seems to be 207 258.38. This seems to be the loan outstanding. We have to repay that by now annual increasing installments. 5-year increasing, 5% per annum compound, and we have annual, right? Yeah, annual installments. So you can say this would be equal to x into v plus 1.05 v square plus 1.05 square v cube just have to calculate your x. Right, now let's go to chapter 14 questions. Question 10. Pension fund has liabilities to pay pensions each year for the next 60 years. Pension paid will be 100 million at the end of the first year, 105 at the end of the second year, this much, so on, increasing by 5% each year. The fund holds government bonds to meet its pension liabilities. The bonds mature in 20 years' time and pay an annual coupon of 4% in arrears. Calculate the present value of the pension fund's liabilities at the rate of interest of 3% per annum effective. So see, because in these questions we use I and stuff a lot, you can directly use tables. We have done that before, but I think here we don't need to. Let's see. So the present value of liabilities will be 100 million at the end of first year, then increase by 5%. Each year for the next 60 years. This is the liability. Then calculate the nominal amount of the bond that the fund needs to hold so that the present value of the assets is equal to the present value of liabilities. So they are saying the fund holds government bonds to meet its pension liabilities. The bond matures in 20 years' time and pays the annual coupon rate of 4% in arrears. Okay, so whatever price it might be, we don't care. We want to calculate the present value of bond. Okay, present value of bond. If you're talking about, let's say, per 100 nominal, let's calculate that. So 3%, we know the coupon rate is 4%, and we'll assume that we will get a redemption at time 20. So 4 A20 plus 100 V raised to 20. This is the present value. Per 100 nominal. So how much nominal should we keep so that we'll get this much present value? Say you'll say your 10852.38 will be equal to, let's say, x into 1.14877. This is nominal that we will have. So x become so we want 9446.91 million nominal. Okay. Third part, calculate the duration of the liabilities. Okay, so here is our present values. Summation T Ct V raised to T would be what? V plus 2 into 1.05 V square plus 3 into 1.05 square V cube and so on. Last would be 60 into 1.05 raised to 59 V raised to 60, right? If you write it in terms of I dash, this will directly become increasing annuity. But one of the 1.5 is missing in each one of them. So I'll multiply, divide, and this will become increasing annuity in arrears for 60 years at the rate of I dash. What would be our I dash? I dash will be, I think 3% was the rate of interest. So 1.0, so 0.03 minus 0.05 by 1.05. Okay, so we have a negative increasing annuity, negative rate of interest. No problem, we'll just store it as it is and use it. Say shift store. Okay, let's check. Yeah. Okay, so you want IA, so first I'll calculate A due. This much into 100 divided by 1.05. And we know our duration would be summation TCT V raised to T by present value. So we already know the present value. duration is 36.1437. Years. Duration of assets. Actually, third part was duration of liabilities. This was third part. Fourth part, duration of assets. So this is what we had. Okay, so if I say summation T Ct v raised to T, we have this much nominal of that. Okay, so because this was per 100, okay, either you can calculate everything per one nominal and directly this will be the value, or because I have already calculated this as per 100 nominal, to this value I will be multiplying 94.96, right? 94.46. 94.4691. This becomes now 4 into IA 20 years plus 100 into 20 into v raised to 20. Okay, again this was per 100 nominal, that is why multiplied 94.4691. Rate of interest is 3%. Of course, this we will divide by the present value and both present values are equal. That is how we got our value of x. So 10852. So duration summation T Ct v raised to T by present value 14.57 years. Of course, because our assets were going only from time 0 to time 20, there was no way our duration would be as high as 36, right? It's not possible. Using your calculations part 3 and part 4, estimate by how much more the value of the liabilities would increase than the value of assets if there were a reduction in the rate of interest to 1.5% per annum effectively. First of all, they are saying using your calculations part 3 and part 4. So we have to use the durations of both of these liabilities as well as assets. Okay, so what we can do is we can use our formula for let's say liabilities. We say change in present value is what? It is tau into present value into another discounting factor into change in interest, right? Okay, so we can substitute all of these to get how much would be the change in liability, present value of liabilities. Okay, I'll say change in present value of liabilities. Just remind me if I'm using the formula correct or not, because sometimes I get confused with this formula, but I think this is what we had. So first of all, the duration was 36.1437 into present value was 10852.38 into discounting factor at 3% would be 1.03 raised to minus 1, and then into change in rate of interest. Change in rate of interest, they said, was 1.5%, but they are saying reduction in rate of interest. I think this was negative of all of this, right? Minus of all of this. As I said, just go through that and let me know, because if rate of interest decreases, the present value increases. I think there should be a minus sign here. Okay, just check and let me know. Okay, so into 0.015 change in rate of interest, so there will be an increase of this much. Okay, what about assets? Change in present value of assets, so minus tau again for assets, present value of assets. Discounting factor is same, rate of change of interest is same. So tau for assets was 14.57. Present value is same for both of them, 10852.38. Discounting factor minus 1. Change in rate of interest 0.015. So there will be change in present value of assets would be 2302.706. So there will be a lower change in assets than in liability. So clearly we'll have loss. What were they asking us? They're saying by how much the value of liabilities would increase than the value of assets. So you'll say increase in liabilities than assets change in present value of liabilities minus change in present value of assets. 5712.308 minus answer 3409.6. Okay, I hope that is given. I hope this is what is given in the solution, but this is how we'll be doing it. Just check the formula once again. Okay, question number 19. List 4 limitations of Reddington. So that is just theory. You can read that, right? State the formula for convexity of a series of cash flow. That is also, you can write it from our sheet. Okay, they're saying a company incurs a liability to pay rupees this much, 1 plus e raised to. So for writing this question, there is a small mistake. It should be 1000 1 plus e raised to minus t by 100, right? This is how it should be at the end of t years, where t is 1 to 40. The value of these liabilities at an interest rate of 5% per annum. Okay, its values, the amount equal to the total value, the liability is immediately invested in two bonds, each bearing 5 interest at 5% per annum, payable annually in arrears. One redeeming at the end of 20 years, the other at the end of 45 years. Both the bonds are issued and redeemable at par. What is the present value of the liabilities? Okay, what is the discounted? Okay, first, everything we have to do for liabilities, because the assets are very easy to calculate, right? Present value of liabilities. This is the cash flow at each of these times. Okay. Time being 1 to 40. Okay, 1000 plus this at the end of 2 years. So if I say present value, okay, what will I have? We'll have summation I going from let me write it as t going from 1 to 40, 1000 1 plus e raised to minus t for 100. So I'll take 1000 out. I will do I will also discount them, right? Discounting v raised to t. So when I split this, I will get 1000 out. Summation t going from 1 to 40. I will have just v raised to t. V raised to t is going to be nothing but, this is an annuity in arrears for 40 years. But what about the other? We have summation t going from 1 to 40 and here I have e raised to minus 1 by 100 v raised to t. So I can say this is annuity in arrears for 40 years, and this is also annuity in arrears for 40 years, but at the rate of I dash. What is I dash? Okay, so I'll say v dash will be equal to e raised to minus 1 by 100 v. Accordingly, we'll have to calculate our I dash. So 1 plus I dash will give me e raised to 1 by 100, 1 plus I being 5%. Okay. So this is our I dash. So this is at for 5% and this is at whatever this rate of interest is. So I'll store this. Just check. Okay. Just I'll calculate both of these separately because I think we'll require these. 40, 5%. Present value of liabilities. This is the discounted mean term of the liability outgo. For DMT, we'll just make it into increasing and increasing. So summation TCT V raised to T 1000 again. You can just go to the table book and find this value because this is just for 5%. We have these values in the table book. IA 40 would be this 2 versus we'll have to calculate this. So first due IA 40 at the rate of I dash will be 198.806 DMT. $14.44. Now just check my calculation one more time because you can see there seems to be a big difference, 13.88 and 14.44. My calculation may have been wrong. Because this is right, Correct. This calculation is correct. Yeah, this is correct. Present value is correct. So these two are correct. Two. This also seems correct. Let me just think then from this point of view. If we just have t here, yeah, it seems okay. It's no problem. IA 40 for 5% is 246.7043. That is also correct. 46.70 plus 190. Okay, clearly I made some mistake. The value here is different. 445510.3 divided by 32101.2. Yes, so 13.88 years. If the DMT of the asset proceeds is the same as the DMT of the liability outgo, how much is invested in each of the bonds? Okay. So we have two bonds here. Both of them, one is going for 20 years, the other is going for 45 years. See, they are saying both the bonds are issued and redeemed at par. Issued at par, that means it is issued, one nominal bond is issued for one. Okay, just because the rate of interest and the coupons are exactly same, right? Rate of interest and coupons are exactly same. So the first equation, you can see both of them are going to, the present value of both of them is going to be 1. Okay, so you can directly write present value of bond A would be equal to 1. You can calculate that. For one nominal, you will get 1 per one nominal, and present value of bond B will also be 1 per one nominal. Okay. So therefore, if I say I bought A of A and B of B, I will get present value that was 32101 point, what was it, 0.2 would be equal to A plus B. And for DMT we will be calculating, so summation T CT V raised to T for bond A. Okay, for this we'll have A amount we bought, and if we are calculating per one nominal, say 0.05 coupons is what we'll get, IA for 20 years at 5%, everything is at 5%, plus 1 is the redemption value that we'll get, V raised to 20. We'll again directly take these values from the table book. 20 0.05 into 1109506, and plus even discounting factor is given here, V raised to n for 20 is 0.37. So this is 5.92442A, and similarly summation TCT V raised to T for bond B would be what? 45 years, B into 0.05, IA 45 plus 1, V raised to 45. So same thing we have to do for 45 years. V raised to 45 would be 0.1113 plus IA 45, so 0.05 into 273. So we'll equate both the summations, this 445510.3 and of course our first equation was this. Let's multiply this value. Okay, so we'll have 5.92442A. What will, of course B will also be 5.9492442A, and for this not plus, I want multiply. Okay, or I'll just make it as 1. Subtract. So B is equal to 5532. So A, if I subtract that from here, okay, I am getting A as negative. Clearly that should not be the case. I may have made some mistakes somewhere. Definitely made some mistake. Let me just try to figure out where I have made some mistake. Hmm. This seems still correct. 190 101. Two five five 329.3. I'm not finding the mistake. Let me just see the solution, okay? See, they have taken p plus q. So first equation is okay. Equation dmt. Okay. So 13.2. Okay, big mistake. While writing these present value, we'll have 20, summation t, and here we'll have 45, right? This is my mistake. Here I'll multiply 20, and this would be 13.08533, and here next equation, here I need to multiply 45, and we'll have 18.66293. Yep, that is what my mistake was. So one equation 13.08533, and here 18.66293. So let's just, we have b here, so I'll just multiply this into 32101.2. So I'll have 599,102.45. Okay. Just taken the b value is equals to 18.66293 and 18.66293. So BB cancelled out in this case, and I'm getting minus here and also minus here. No problem. So A will be 27537.3, and B would be 32101.2 minus 27537.3, 4563.9. Okay. Okay. Next, let's jump to assignment question, chapter 19 to 24. Question number 3. a life insurance company sells a 15-year guaranteed income endowment product to a male life aged 50 years exact. Under this product, premiums are paid for the first 10 years of the policy, 10 policy years annually in advance. Starting from the 11th year, an annual guaranteed benefit of rupees 250,000 is paid on survival. However, if the policyholder dies within the first 10 policy years, he gets a benefit equal to the amount of the premium paid till date. Whereas if the policyholder dies post completion of 10 policy years and before the end of the policy term, he would get a sum of 1 million along with the sum of all future remaining annual guaranteed benefits. Okay, so how does that work? We'll talk about it in a minute. Calculate the annual premium assuming AM92 mortality, 6% per annum interest and no expense commission. Okay. So expected present value of premium, we have first 10 years. So premium into A due, age was what? 50. So 50, 10. You can directly get that from the endowment table. And let's talk about the benefit. So first 10 years is very straightforward. If the policyholder dies within the first 10 years, he gets a benefit equal to the amount of premium paid till date. Whereas, so first is premium paid till date. What does that mean? That means if the person dies within the first year, then there was only one premium paid, that was at time 0. So the person gets P amount. But if the person dies in the second year, then 2 premiums were paid at time 0 as well as at time 1. So the person will get 2P. If the person dies in the third year, then 3 premiums were paid. So the benefit would be 3P and so on. So we have increasing benefit, increasing premium benefit, or whatever you want to call it. We have simple increasing benefit, right, for the first 10 years. So we'll have P, I, A, 10 for the first 10 years. This is the benefit, okay. Then they are saying that starting from the 11th year, an annual guaranteed benefit of 250,000 is paid on survival. So each year as the person survives, an annual guaranteed benefit is paid of 250,000. Okay. So if a person survives for the first 10 years, so we'll have V raised to 10, 10P. Okay, first of all, big mistake here, right? What do we have? Select 50-10, right? This is how we'll write. Then now V raised to 10, 10P select 50. If the person survives for the first 10 years, then what happens? 250,000. Right now the person is age 60. So I'll say an annuity, okay, paid on survival. Okay, they said start of 11th year, an annual guaranteed benefit of this much. So as soon as the person survives the 10th year, the person gets this much amount. If the person survives the 11th year, gets another this much amount. Survives 12th year, another this much amount, and so on. So there's an annuity in advance for a person who is age 60 going for 5 years, right? So this is nothing but an annuity given for the next 5 years. But what happens if the person dies within this particular time? So if the person survives the first 10 years and dies in the 11th year. So if the person dies in the 11th year, then what is happening? They are saying 1 million is given. Okay, here 1 million, I'll just write as 1. Okay, along with the sum of all future remaining annual guaranteed benefits. So see, The person survived the 10 years, got a 250,000. Okay, 250,000. I will just write it as 0.25. Got 0.25. Okay. But if the person dies within this year, then he was supposed to get 4 more 0.25. So again, I'll just write it. If the person survives, survival benefit, what was supposed to be 0.25, 0.25, 0, 12, 13 and 14. Okay. At the beginning of each year, 0.25. This is what was supposed to be paid. If the person dies within the first year, that is between 10 and 11, 1 million is given plus all of the future remaining values. So the person is going to get 1, and this is how much? This is another 1. So the person is going to get 2 million here. So this is death benefit. So if the person dies within 10 and 11 year, the person gets 2 million. What happens if the person dies between 11 and 12? If the person dies between 11 and 12, the person gets 1 million plus the remaining, that is this 1.75 million. If the person dies within the third year, that is between 12 and 15 or 12 and 13, then the person gets 1.5. Here the person will get 1.25 and here just 1. So you can see the death benefit is nothing but a decreasing benefit, right? So I can say this is plus. Yes, Dhruvika.
So here, why can't we take as 0.25 as annuity certain as an 0.25 A5, ADU 5, and then add the death benefit of 1?
Yes. Now that is what the mistake I did when I first solved this question. I'll tell you why not. Because what is happening is when we say there's a guaranteed benefit of 0.25, because they use the word guaranteed, right? So if when I say 0.25 and ADU for 5 years, if the person survives for the first 10 years, right? Now the problem here is, this says irrespective of whenever the person dies, we will give them 0.25 at 10, 0.25 at 11, 0.25 at 12, and this is exactly the benefit that we will be giving them. Okay, this is what our guaranteed benefit says. But what is happening here is, if the person dies within the first year, that means within 10 and 11, what did the person get? The person did not get 0.25 each year. The person got 0.25 at time 10 and then 2 directly at time 11. So the present value will be what? Present value would be 0.25 plus 2 discounted for only 1 year, if I am discounting it back to time 10, right? Whereas here, what did we have? Here we had all of those values discounted for at different times, right? So the discounting part is what makes the big difference here, because they said we are giving whatever remaining amount was, we are giving that at the time of the death benefit payment. That is why we cannot write like this, because here we are discounting each one of those values at different times, whereas at death benefit we are giving all of them combined together. So the discounting part is what is going to make the difference. Okay, so decreasing death benefit 0.2, or I'll write it as 225,000 A select, no select, because now the person is age 60 dash 5 years, and then plus 250,000, sorry, minus 250,000 IA 60 dash 5 years. Now this is going to start after 10 years, right? So I should write that as well. P raised to 10, 10p select 50, and then this. Okay. So this we can directly get from the table book. We are talking about 6% rate of interest. 6% tables. Edu select 50 10, so 60 57.698. For this we will have to solve. And this we can get from the table, no problem there. So let's calculate this. click the wrong button. So see, this value and this value we can get from the endowment 65 table. Percent endowment 65, this 60 and 65. This value directly we can take 4.39. Just write it here. Okay. A65 60. Plus 10 to A60. A select 50. Let me just check one more time. A select 50 and I is 6%. I is it seems correct. It I think I have all the values. We want premium 7.698 minus this much. Is equal to, if it's this is going to be the premium. I hope that is what our answer is. Okay, that is not given here, so please check and let me know that the answer is correct or not. For the second part, they are saying if the gross premium reserve at the end of 10th policy year is 12000 whatever, calculate the gross premium reserve at the end of the 9th year using the recursive relationship between the reserves and the successive interval. We can assume the following reserving basis for this purpose. So we are going to take into account our recursive relationship. Now see, they are saying our reserving basis is not changed. Instead of earning 6% rate of interest in reserves, we are only earning 4% rate of interest. That is what they are saying. So whenever we are calculating reserve, we have to take into account only rate of interest of 4%, not 6%. So they are saying our 10V is given as 1200000. This is the amount of reserve that was kept at time 10. They are asking us to calculate the reserve at time 9. So what is happening between time 9 and time 10? So you are saying at the beginning of time 9 we will receive premium and we will have reserves that will be released at time 9. There's no expenses, so we don't have to worry about that. At time 10, what is happening? At the end of this year, if somebody dies, we will have to give them premiums that was returned. Okay, so in 10 years 10 premiums were returned, right? So we'll have 10p returned for anybody who dies in this particular year, so q 59. And for whoever that is surviving in this year, okay, whoever surviving in this year will have to keep reserve, so 10v would be the reserve that is kept for p 59. So p plus 9v into 1.04, because 4% is our reserving rate of interest, will be equal to 10p q59 plus 10v p59. So we already have these values. So I'll say 10 into answer into q59. q59p 0.00714 plus the reserve kept was 1200000 for anybody who survives, so 1 minus 0.00714. Then we will discount, so divided by 1.04, and then we will subtract one premium. Minus one premium was 8238.5.07. This becomes the reserve kept at time 9. By recursive relationship. Okay. Question number 4, second part. Okay. So first part I think is done. That is, monthly premium was easy to calculate. I will just make the equation and I will directly take the question from solution from the answer from the solution. So life insurance company specializing in with profit product sells limited pay with profit endowment policy to male life aged 50 exact. The sum assured plus declared revisionary bonuses are payable on survival to the end of the term or on death if earlier. So see, they are saying the sum assured is paid on death. So immediately on death, right? Premium payable 10 years. Policy term is 15 years. Sum assured is this much. Okay. Initial commission, initial expense, renewal commission, renewal expense. Okay. I'll make equation for all of them. And then future revisionary, or did we do this part I think before, right? Anyways, I'll quickly make. And then they are saying future revisionary bonus 1.92 308, so it will make our 6% into 4%. Okay, and interest rate 6%. Premiums are payable monthly in advance, and the benefits are paid the end of the, okay, benefit is paid at the end of the year of death, not immediately. Okay, so here they have specified at the end of the year of death. So expected present value of premium 12p, a due payable 12 times. Premium was supposed to be paid only for 10 years, but what is the age when we are starting? Age 50. Mortality is M92 ultimate, so we'll have 50 going for 10 years. Okay. Then benefit, we'll take death benefit and survival benefit separately. So because the sum assured is said to be compounded and vested at the end of each policy year. So at the end of each policy year, that means the bonus of the current year would not be given in the death benefit of this year, would be given in the next year. Okay, so we'll have our sum assured, whatever. I'll just check. This is, it was 1 million, I think. Yes, 1 million divided by 1 plus b. We'll have a 50-10. This goes for at the rate of 4%. And then survival benefit, we'll say complete bonus of 10 years, actually 15 years. The policy is going for 15 years. So complete bonus of 15 years would be given. Sum assured was this much. And I can directly say it would be V raised to 15, 15p 50. This would be at the rate of again 4%. What about expected present value of expenses and commission? Initial commission 20% of the sum of the monthly premium first year payable at the outset. So 12p would be the complete premium that we are talking about, 20% of that, so 0.2 into 12p. Then initial expense, they're saying 2,500 plus 35% of the monthly premium of the first year incurred at the start of the policy. So again, instead of 0.2, this just becomes 0.55 plus 2,500. Okay. And plus renewal commission 2% of the renewal premium payable from the second year. We'll just see if there is more here as well. 400 at the start of each year from the second year to the 15th year, and here 1.5% of the renewal premium of the from the second year. So we'll just add these two. So we have 0.035 of, what did it say, renewal premium from the second year. In both of these cases we have renewal premium from the second year, so we'll be removing the complete premium of the first year. So into 12p, and I'll have a due payable 12 times from age 50 10 minus a due payable 12 times 51. Okay, 1 year. So we'll be subtracting 1 year completely from here. Remember one thing, that a due x1 will always be 1. This is annuity payable at time 1, at time 0, right? That would be 1. This will always be equal to 1. So you can use that and then whatever payable 12 times, so minus m minus 1 by 24. This is what we get always payable 12 times. This is what we'll get. Okay, so calculate that accordingly. Then they said 400 at the start of every year from the second year to the 15th. ADU 50, 50. Okay, that's it. These were everything. Now you can calculate these values, okay, and calculate the premium, whatever premium might be. I will directly take it from the solution. I'll open the solution. So the premium we are getting is 7113.12. This is what the question was, right? Yep, the question seems correct. Second part. At the end of the 10th year, for surviving policy, the company has declared a bonus at a constant rate of 12% over the last 10 years. Calculate the gross premium reserves at the end of the 10th year basis the following reserving assumptions. You can see reserving assumption is different from the pricing assumptions. So we'll have to take now whatever future rate of interest, we have to take it as 5%. Future bonuses, they have said 4%. In past, they have said 2% was the bonus, right? You can see here 2% over the last 10 years. But in future, they will give 4%. Expense same as pricing. So we have to calculate 10V using prospective reserves only. First of all, the premium was given only for the first 10 years. No premium paid after 10 years. So we will not be taking any premium or expense based on premium while we are taking these reserves. Before we calculate this, we should calculate how much is the sum assured. Sum assured after 10 years. So that means if a person dies at time 11, how much the person would get? The person would get the original sum assured plus 2% over the last 10 years. So original sum assured was 1 million, right? Into 1.02 raised to 10. This is the value that the person will get because this is the bonus that was declared. This is the amount that they'll get at time 11 if the person dies between 10 and 11. And later on 4% bonus would be declared. So 10B would be this 121,899.42 divided by 1.04 because 4% is the later on bonus into death benefit. Death benefit is how much? death, benefit on death. So 10 years have already passed. Now the rate of interest will not be will not be this, right? 4%, because see here the rate of interest is 5% and future bonuses are 4%. So I cannot directly write it that ways. I will have, or you can just write it like this, that if the person dies within the first year, then discounted, okay, Q 60 plus 1.04 V square P 60 Q 61 okay, and so on. So here we'll have to write all the 5 values. We'll just say and so on. 1.04 raised to 4 V raised to 5 4P 60 Q 64. This is going to be my last value. And out of these expenses, what is going to be left? Initial expense. Will not have initial expense. These were related to premium. No premium is paid after this, so no expense of this, but this will still be left. So plus 400 ADU 60 and 5. Let's calculate this. Okay, so this I can write it in terms of D as well. Remember we have talked about this before, that write these in terms of D. So I'll just directly write what will it be here. V D60 plus I'll have 1.04 V square D61 and this will go on till 1.04 raised to 4 V raised to 5 D64 divided by L60. This is what we'll get. So this is what we'll calculate and I'll directly write it here. Okay. V is 5%. D60. D60 plus 1.04 into 1.05 raised to minus 2 D61 because could have calculated I dash and did this. No problem. Maybe you would have less calculations here. Divided by L60. L60. This much into this. plus 400 into this value 60 and 5 we can directly get from 65, but okay, we cannot directly get from 65 because again we are talking about 5% rate of interest. So ADU 65 for 5% rate of interest would be what? 1 plus, if the person survives, everything would be according to the person survives. If the person survives for the first year, the person gets the amount v square 2p60 v cube 3p60 p raised to 4 4p60. If you convert this into L, you will get L60 plus VL61 plus V square L62 V cube L63 V raised to 4 L64 divided by L60. This is how you can write this. This much into 400. So the reserves, the end of 10 years would be 58787 point. Okay, I did not take one thing. I did not take the survival benefit into account, right? This was death benefit. What about survival benefit, right? Because we do have survival benefit, right? Yes, we do have survival benefit also. So forgot to take that into account. So plus what's the survival benefit? After 5 years, we'll have complete bonus. So this much, or I can just write 100,000 to 1.02 raised to 10 into 1.04 raised to 5 into whoever survives. So p raised to 5, 5p, 5p60. calculate that separately. P raised to 5 and then 5p60. So L65 and 60. And just okay. Reserve at time 10 becomes okay. Let's see. 1162561, yes, so nearly same. So we'll end our class here. We'll clearly not be able to solve other questions because all these questions are very lengthy, right? So let's end our class here and we'll meet for Excel lecture day after tomorrow. Okay, for Excel lecture I would be taking reserves. Okay, so premiums and reserves. So make sure you revise all the concepts of premiums and reserves for the Excel lecture. Okay, bye.